Question 1 asked you to find the mean of all 10 possible samples. I did that right here. For each of the 10 possible samples, I added the 3 numbers, and I divided the total by 3, and I got these 10 answers down here. So these 10 sample means are the answer to question 1. Question 2 asks, the middle 80% of the possible samples are between which two sample means? We have 10 possible samples, and 80% of 10 is 8. So the middle 80% of the 10 samples is just the middle 8 of the 10 samples. And if you leave out sample 1 and you leave out sample 10, there's 8 samples in between. So these 8 samples in here are the middle 80% of the 10 samples. The lowest sample in the middle 80%, which is sample 2, has a mean of 34. The highest sample in the middle 80%, which is sample 9, has a mean of 38. So 80% of the possible samples are between these two sample means, because these are at the outer edges of the middle 80%. So you could, your answer to question 2 would just be 34 and 38, because 80% of the possible samples are between those two sample means. So the answer is just 34 and 38. Question number 3 asks, what's the 80% margin of error? To find that, first we have to find out what the population mean is. The population mean is 36, which is right here. It's these two numbers. What we need to do is we need to find out how far the population mean of 36 is from these two sample means at the outer edges of the middle 80%. The distance from the population mean of 36 to these two outer sample means is the 80% margin of error. And the easiest way to find the 80% margin of error is to just take the mean of the highest sample in the middle 80%, which is 38, and subtract it by the population mean, which is 36. So 38 is the mean of sample 9. It's the mean of the highest sample in the middle 80%. And we want to subtract that number by the population mean of 36. And we get 2. So our 80% margin of error is 2. And that makes sense because the distance from 36 to 38 is 2. The 80% margin of error is also the distance from the population mean of 36 to the mean of the lowest sample in the middle 80%, which is 34, because 36, the distance between 36 and 34 is 2. Now, so the 80% margin of error is 2. The 80% margin of error is the distance from the population mean to the two sample means at the outer edges of the middle 80%. Now, you wouldn't want to subtract 34 by 36 to get the margin of error, because that would give you negative 2. And the margin of error is always supposed to be a positive number. The reason why it's a positive number is because it's a distance, and distances are always positive. So it would the margin of error, the 80% margin of error is 2. So that would be your answer to question 3. Remember, the margin of error has to be a positive number. The next question asks you to create an 80% confidence interval, and it asks you to do it 3 times. It says do it 1 time with sample 1, which is below the middle 80%. Do it with one of the samples from the middle 80%, which is one of the samples between sample 2 and sample 9. And do it with sample 10, which is above the middle 80%. Let's do it with sample 1 first. To get an 80% confidence interval, you add and subtract the 80% margin of error. Subtract 2. Remember, this sample mean is coming from here. It's the mean of sample 1. We're taking the mean of sample 1, and we're adding and subtracting the 80% margin of error, which creates a confidence interval around the sample mean of 33. We get 31 and 35. So when we take the mean of sample 1 and we create an 80% confidence interval around it, the 80% confidence interval is 31 to 35. Now let's do it with one of the samples from the middle 80%. We can use any sample between sample 2 and sample 9, meaning anything inside the circle. Let's do it with this sample right here. It has a mean of 37. If we want to create an 80% confidence interval around this sample mean, we just add and subtract the 80% margin of error from the sample mean. So 37 minus 2 and 37 plus 2 gives us 35 and 39. So when we create an 80% confidence interval with the mean of this sample, with the sample mean of 37 right here, we get a confidence interval of 35 to 39. Now we have to do it with sample 10. The mean of sample 10 is 39, so it'll be 39 minus 2 and 39 plus 2, which gives us 37 to 41. So these are all 80% confidence intervals because they were all created by adding and subtracting the 80% margin of error, which was 2. So this answers 3 of the questions. Well, no, this answers question 4 because these were the 3 80% confidence intervals that I asked for in question 4. I would want to label them somehow. I would want to label these to remember that they're 80% confidence intervals. So maybe I could write 80% CI next to each of these. And also, I would also want to label this one and this one with 80% CI. Now the next 3 questions ask, Did the confidence interval you created with sample 1 include the population mean? This 80% confidence interval did not include the population mean of 36. 36 is above 35. So whenever you use a sample below the middle 80% and you create an 80% confidence interval with it, the confidence interval does not include the population mean. When we took a sample from the middle 80%, which was this one, and created an 80% confidence interval right here, it did include the population mean because 36 is in here. When we took a sample above the middle 80%, which was sample 10, and created a confidence interval with it, it did not include the population mean because 36 is down below 37. So the main point is when you create an 80% confidence interval, it'll only include the population mean if the sample came from the middle 80%. Let's look back here. So the answers were no, yes, and no for 5 through 7. No, yes, no. The next question says, the middle 60% of the possible samples are between which two sample means? Well, 60% of 10 is 6. So the middle 60% is the middle 6 of the possible samples. If you leave out the bottom 2 samples and the upper 2 samples up here, and you take the 6 samples in between, those are the middle 60%, because it's 1, 2, 3, 4, 5, 6, and 6 is 60% of 10. Now the lowest sample in the middle 60%, which is sample 3, has a mean of 35. The highest sample in the middle 60%, which is sample 8, has a mean of 37. So for that question, you would say the middle 60% of the possible samples are between 35 and 37. It's between those two sample means. So your answer to question 8 would be between which two sample means. Your answer to question 8 would be 35 and 37, because 60% of the possible samples are between those two sample means of 35 and 37. The next question asks you for the 60% margin of error. We find this the same way as we did with the 80% margin of error, except now what we want to do is we want to subtract the mean of the highest sample in the middle 60%, which is the mean of 37, by the population mean. So remember, when we got the 80% margin of error, we subtracted 38 by 36, because to get the 80% margin of error, you take the mean of the highest sample in the middle 80%, which was 38 right here, and subtract it by 36. But now, to get the 60% margin of error, we take the mean of the highest sample in the middle 60%, which is 37, the mean of sample 8 right here, and subtract it by 36. Which equals 1. So the 60% margin of error is 1. It's the distance the distance from the population mean of 36 to the sample mean at the outer edge, the sample mean at the upper edge of the middle 60%, which was this sample right here. So this was a distance of 1. The 60% margin of error is also the distance from the population mean of 36 to the sample mean at the lower end of the middle 60%, which is the sample mean of 35. So the distance from 36 to 37 was 1, and the distance from 36 to 35 is also 1, because 35 is 1 below 36. So 2 is our 80% margin of error, 1 is our 60% margin of error. So remember that the black circle is the middle 80%, and 38 was at the upper end of that circle. So to get the 80% margin of error, we subtracted this number, 38, at this outer edge by 36. The red circle is the middle 60%, and 37 is at the upper edge of that circle, of the middle 60%. So to get the 60% margin of error, we subtracted 37, which was at the upper end of this circle, by 36. So our answer for the 60% margin of error is 1. The next question asks for us to create 60% confidence intervals. To get a 60% confidence interval, you add and subtract the 60% margin of error. And it says for us to do it with one of the samples below the middle 60%, meaning below the red circle. That could be sample 1 or sample 2. You have to just do it with one of those. We can do it with this sample right here, sample 2, which has a mean of 34. Let's take it and add and subtract the 60% margin of error, which is 1. We get 34 to 36. No, sorry, 34 to 35. This was a 60% confidence interval because we added and subtracted the 60% margin of error. Remember, back when we were adding and subtracting the 80% margin of error, we were creating 80% confidence intervals. But now that we're using the 60% margin of error, we're creating 60% confidence intervals. Now we have to do it with one of the samples from the red circle, meaning one from the middle 6. The middle 60%. We could do it with this sample right here, which has a mean of 36. So let's take this sample mean of 36 and create a confidence interval. We just add and subtract 1 from 36. Confidence interval is always the sample mean plus or minus the margin of error. the margin of error that you use determines whether it's an 80% or a 60% confidence interval. So this one will be 35 to 37. Now we just need one more confidence interval. I told you to also pick a sample from above the middle 60%, which would be one of these two samples that are above the red circle. Let's do it with this sample right here, which has a mean of 38. We take the sample mean of 38 and we add and subtract 1 to get a 60% confidence interval. It goes from, the confidence interval goes from 37 to 39. So now we've created three 60% confidence intervals. Remember that the margin of error is just a number. The 80% margin of error is the distance from the population mean to the outer edges of the middle 80%. The 60% margin of error is the distance from the population mean to the outer edges of the middle 60%. So the margin of error is just a number. A confidence interval is a span or a range between two numbers. So a confidence interval isn't just one number. A confidence interval will be something to something. Like this entire thing right here is a confidence interval. We've created 6 confidence intervals so far, 3 80% confidence intervals and 3 60% confidence intervals. The next questions ask you about when these confidence intervals included the population mean. When we took a sample from below the middle 60%, below the red circle, and created our confidence interval, it did not include the population mean. So the confidence interval, when we took the mean of sample 2 and created a 60% confidence interval, it did not include the population mean of 36. The reason why is because if you pick a sample below the middle 60% and you create a 60% confidence interval with it, it doesn't work. It doesn't include the population mean. When we took a sample from the middle 60% in the red circle and we created the confidence interval with it, it did include the population mean because 36 is between 35 and 37. But when we took a sample up here, one of these two, and created the 60% confidence interval here, it did not include the population mean of 36. 36 is down here. So let's look at questions 11 to 13. Did the confidence interval include the population mean when you used one of the samples below the middle 60%? No. Yes for 12, and no for 13. So just like before, it's yes, no, yes. If you're creating an 80% confidence interval, it'll only work if the sample comes from the middle 80%, from the black circle. If you're creating a 60% confidence interval, it only works if it comes from the middle 60%, meaning it'll only work if it comes from the red circle. Next questions ask about the confidence coefficients. I'll start a new page. So we know that the black circle includes the middle 80%. The red circle has the middle 60%. And we know that 38 is the sample mean that's at the upper end of the middle 80%, because it's at the upper end of the black circle. So if I take this sample mean of 38 and use it to create a z-score, the z-score that I calculate will be called an 80% confidence coefficient, because the z-score is located at the upper end of the middle 80%, at the upper end of the black circle. So the fact that the reason why it's called the 80% confidence coefficient is because it's located at the upper end of the middle 80%. That's why it's an 80% confidence coefficient and not just a z-score. Well, I guess my point is, it is a z-score, but it's a special z-score because of where it's located. So the z formula is like this. Sample mean minus population mean over population standard deviation sigma over square root of n. So we take the sample mean of 38, minus the population mean of 36, over sigma of 4.24, divided by the square root of n. N is 3 because, well, each of the samples includes 3 numbers, so the sample size is 3, because all of these have 3. Let's see what this equals. First, let's find the square root of 3. It's about 1.73. Square root of 3 is about 1.73. We divide on the bottom. Let's divide 4.24 by 1.73, we get 2.45. So it's 38 minus 36 over 2.45. Now we subtract on top. 38 minus 36 is 2. It's 2 over 2.45. Which is about 0.82, 0.816. So this is our answer to question 14, 80% confidence coefficient. To do this question, all we have to do is find the outer edge, the upper edge of the middle 80%, which is the upper end of this black circle. We have to find the sample that's at that upper edge, meaning the highest sample inside of the middle 80%, which is this one right here. See how this is located at the upper end. We have to take the mean of that sample, which is 38 in this case, and plug it into the z formula. See how the 38 goes in right here? Once you get the z-score, your final answer is the coefficient. Now, the next question asks for the 60% confidence coefficient. It's the same steps as we just did before, but now we're dealing with a different boundary. We're going to work with the upper end of the middle 60%, which is this boundary right here. So the question says, what is the 60% confidence coefficient? To do this, we want to find the upper end of the middle 60%, which is the upper end of this red circle. We want to look at the highest sample in the middle 60%, which is this sample right here, because this sample is located right at this boundary point at the upper end of the middle 60% right here. We want to take the mean of that sample, which is 37, and plug it into the z formula. So the confidence coefficient is just a boundary z-score. It's the z-score at the upper boundary. If it's at this boundary, it's a 60% coefficient. If it's at this boundary, it's an 80% coefficient, because the red circle is 60%, the black circle is 80%. So the sample mean of 37. Everything else is going to be the same. The population mean is still 36. The standard deviation is still 4.24. There's still 3 numbers inside each of the samples, so n is 3. Now notice how we already know that the bottom of the fraction comes out to 2.45. So let's just put 2.45 down here. So let's see what this equals. -1 divided by 2.45. 1 divided by 2.45 is it's about 0.41 rounded. And it's a negative answer because we're dividing a negative number by a positive number. Actually, it shouldn't be negative. Wait, what am I doing? This should have been a positive 1. 37 minus 36 is positive 1. So it's a positive answer. That was my mistake. So it's plus positive 0.41. So 0.41, 0.82 was the 80% coefficient. 0.41 is the 60% coefficient. So both of these were z-scores at the upper boundary, but one of them was at this boundary, one of them was at this boundary. The next question asks you to calculate the margin of error using a formula. Calculate the 80% margin of error by multiplying the 80% confidence coefficient by the population standard deviation over the square root of the sample size. That's number 16. What we can do, this is the formula that we're going to be using. It's not the z formula, which we were using before to get the confidence coefficient. It's actually the margin of error formula. So it has a z inside of it, but it's not a z-score formula. Let's get our 80% confidence coefficient, which came out to 0.82. Plug it into z. Multiply it by sigma over the square root of n. We know our population standard deviation is 4.24. So the population standard deviation is is sigma. That's what sigma stands for. So it's 4.24 right here. Over the square root of n. N is still 3 because each of the samples has 3 numbers. Now, notice how this is just the bottom of the z-score formula. This was our 80% confidence coefficient from down here. We plugged it in here. But this is just the bottom of the z-score. So we know that that equals 2.45. It's 0.82. We know that all of this is 2.45. So it's 2.009, which is very close to 2. We can just round it and say that it's 2. So this formula gave us the 80% margin of error. It gave us the same margin of error that we had way back here, which was the number 2. So it's just another method for finding the 80% margin of error. The final question, which was question 17, is asking us to use the 60% confidence coefficient to calculate the margin of error. So now we're at question 17. It's going to be the same steps, except now instead of having the 60%, instead of having our 80% confidence coefficient of 0.82 plugged in here to z, it's going to be this other 60% coefficient of 0.41 that's going to be plugged into z. I could label these as CC for confidence coefficient. So now we're going to be plugging this one, the 0.44, into z, and we'll get the 60% margin of error. So now it's 0.41. This is still the same. We know that the inside of this parentheses comes out to 2.45. Multiply it by 0.41. Multiply these two numbers. Comes out to very close to 1, which was our 60% margin of error way back at the beginning. So it's just another method of finding this margin of error right here. So this was the margin of error formula. You take the 80% coefficient and plug it into the margin of error formula, you get the 80% margin of error, which is 2. You take the 60% coefficient right here and plug it into the margin of error formula. You plug it into z, you get the 60% margin of error. So when the 80% coefficient goes into z, you get the 80% margin of error. If the 60% coefficient goes into z, you get the 60% margin of error. So our final answers were just, the answer to question 16 was 2, and the answer to 17 was 1. Those were the two margin of errors.